Hello Science 30s. This next lesson is on pH and hydronium. So hydronium is a new molecule to you guys, a lot of you anyways, and I just wanted to go over that a little bit today. So we understand from previous courses that pH is the power of hydrogen. And what you have not learned so far is what happens to that hydrogen ion. And in solution, what happens is that hydrogen ion is going to react with water to form hydronium. So what this looks like in a chemical reaction is this right here. And the only thing that we need to realize here then, guys, is that H3O positive, the hydronium ion then, is the acidic chemical. It is the chemical that gives acids their strength. And so obviously the more hydronium you have, the more acidic something will be, and therefore the lower the pH. Alternatively, the higher the pH, the lower the hydronium ion concentration and the more basic something is. Or, if you want to just use the word acid there, the weaker an acid it will be. And when we get into hydronium ion concentrations, the numbers are staggeringly small. 0.0000000024, for example. And whenever humans come across numbers like that, we don't understand them very well. And so what we have done is used the logarithmic scale and used pH in order to describe the hydronium ion concentration. So the first thing we're going to look at then is how to convert hydronium ion concentration into pH. And so we have the pH, the formula is right here on page 11 of your data booklet. We have two formulas there that are really important, and then just the definition of what those square brackets mean. And so if you're going to be converting from hydronium ion concentration into pH, then you're going to be using this formula right here. pH will equal the negative log of the hydronium ion concentration. So I have two questions here, two examples where I've given you hydronium ion concentration. So then the pH is going to equal the negative log of, in this case, 0.00100 moles per liter. So in order to do that question, I would get my calculator out, right there. Hopefully you guys can see that. Maybe I'll move it over here and move this over here. And so this is going to be the negative right there, negative log. And the negative button I used is right down near the bottom. I'm not going to be able to get the whole screen in here, but that's your negative button right there. So the negative log of 0.00100, and we end off our bracket and we land up with a pH equaling 3. Now in this particular question there is 1, 2, 3 significant digits, and so properly written out in pH that would be 3 numbers after the decimal, and that would be our answer. Give you a second to look at that. Now, let's go to the next question. The next question, the hydronium ion concentration is equal to 2.00 times 10 to the negative 4 moles per liter. So my pH is going to equal the negative log of the hydronium ion concentration, which is 2.00 times 10 to the negative 4 moles per liter. And this is going to equal, once again, we get our calculator out, we'll clear that, and we will go the negative log of 2.00 times 10 to the power of negative 4, and that bracket, and there is our number right there. So this would equal 3 now in this case we have 1, 2, 3 significant digits, so we need 3 numbers after the decimal. So this would be 698 and so we would stop at the 8. The number after the 8 is a 9, so this would be 699. And there would be my final answer. pH does not have units. Okay. The next question we're going to go over is converting from next 3 questions I have here is converting from pH into hydronium ion concentration. Once again, on page 11, here is your formula. The hydronium ion concentration is equal to 10 to the power of the negative pH. So start off with a relatively easy question. We have the hydronium ion concentration, which will equal 10 to the power of negative 7.00, and obviously if we put that in our calculators, it just goes 10. So we go 10, and then we want to find to the power button nut right there, 10 to the power of negative 7. And we can put 00 there as well. And obviously that's just 1 times 10 to the power of negative 7. And so I would just write this out as 1 point. Now, in this case, we have 2 numbers after the decimal, which means we need 2 sig digs in our answer here. So that would be 1.0 times 10 to the negative 7. And there are going to be units for this one, and that's going to be moles per liter. For B, we'll just switch it up here now to some different numbers. And so we have a hydronium ion concentration is what we're trying to find, and that's going to be equal to 10 to the power of negative 2.09, which is going to equal, and so get out the calculator here again, we go 10 to the power of negative 2.09, and there is our pH. That is a really low pH. Sorry, that is a hydronium ion concentration. That's what I meant to say. And so we have to convert that now. Now we can either say 0.00, and again in this case we're going to need 2 numbers, two significant digits. So this would be 81 moles per liter. Or we could go 8.1 times 10 to the negative 123, and that would still be in moles per liter. Either one of those answers, if it's numeric response, normally they will expect you to, or we would expect you to put it into that form here with the scientific notation. Okay, the last one we have is now getting into a basic pH. So here we were acidic. The first question we were neutral, and now we're into basic. And afterwards we're going to compare all of these hydronium ion concentrations. So here our hydronium ion concentration is going to equal 10 to the negative pH, which is 10 to the negative 8.67. Off my page there. And this is going to equal, clear that, and then go 10 to the power of negative 8.67. And look at that, nice and easy. They put it right in, because it's such a small number, right in to our calculator. We can just read it right off to 2 sig digs. So this would be 2.14 times 10 to the negative 9, and this is in moles per liter. Now let's take a look at these 3 numbers here. We started off with a neutral pH. We then went to an acidic pH, and then to a basic pH. Here it's times 10 to the negative 7. Here it's times 10 to the negative 3. That's a much bigger number. And then here we have times 10 to the negative 9. And that is a much smaller number than for example, this one. And that makes sense, because as our pH increased, we should expect our hydronium ion concentration to go down. So let's write that down. As pH increases, hydronium ion concentration decreases, and vice versa. And that's how you do hydronium ion concentration. Thank you.